Okay, today inshallah we are going to be covering the last point in the horizontal curve design, and which is basically the horizontal side distance offset, which is the horizontal side distance offset. What do we mean with the horizontal side distance offset? Which is basically if that's the horizontal curve, okay, and that's the vehicle trajectory that we can see here, okay. Drivers of a car here must have a clear sight line. So if there's an obstacle here, they can see it. That's what we mean with horizontal side distance offset. That there, from this point to this point, everything should be clear and the driver can see through. So basically this distance, let me just, this arc the length of this arc is basically the side distance. So we need to have this chord, clear, and the line of sight clear in this area. So in order to do that, we have to calculate, first of all, the side distance, which depends on the speed of the vehicle. Okay, then we have the radius, that's an input. Then we calculate the HSO. So to derive, actually I don't go with these numbers. I just, derive it from the first principles. So let me just work on it with you. So basically, if that's the horizontal curve, and this, this part from here to here, this segment is equal to this stopping side distance for the driver, then we need to have this line of sight clear. There is no obstacle. So the first obstacle can be starting from here. يعني يا شباب في المنحنيات الأفقية بنحاول أو مش بنحاول، يجب يكون في مجال الرؤية مفتوح لقائد السيارة، تمام، بحيث ان هو يقدر يشوف لو في عائق هنا يبعد بمسافة الوقوف تبعه. يعني لو دي السيارة بتاعتنا هنا اهي، تمام، فاحنا بنحسب الديستنس دي اللي بنسميها horizontal side distance offset. طب هنحسبها ازاي؟ هي بالظبط كده. لو اخدنا هنا ده السنتر and this is the radius, okay, and maybe the curve is still continuing. There is another angle for the curve, which is basically the delta or the deflection angle. But what we have here is different. We have here angle theta, and this is theta over 2. So theta, first of all, the stopping side distance equal speed multiply t PRT plus V square divided by 2 G F. So that's the stopping side distance. Then we calculate theta. Theta equal the stopping side distance divided by R. And theta must be, it's going to be in radians this way. So we have to convert it to converted to degrees. So we have to multiply it 180 divided by pi. Then this distance equals, that's the HSO, equals R minus R cosine theta. I'm sorry. Cosine theta over 2, which is R multiply 1 minus cosine theta over 2, which is basically cosine theta. This is theta. So it's basically, let me just so theta over 2 will equal, divide, so it's the stopping side distance multiply 90 divided by pi over R. Can someone, if we calculate this, 90 divided by pi divided by, so this is going to be 28.64. So here it's 28.64 multiply stopping side distance divided by R. Okay, and that's basically what we have here. Clear؟ أي سؤال يا شباب؟
دكتور معلش بس الستوبينج سايد ديستنس ايش علاقتها بالكير؟
اوكي، that's a good point. سؤال ممتاز. انا دلوقتي ايه الغرض من القصة دي كلها؟ انا الغرض ان لو حد سايق السيارة هنا، تمام، يبقى كاشف الطريق على اساس ان هو لو في اي حاجة هنا، مثلا في سيارة مقلوبة، في اكسيدنت، في اوبستكل، لو هو مش شايف على مسافة الستوبنج سايد ديستانس دي، تمام، يعني انا مديله سرعة هنا مثلا 90 كيلومتر في الساعة، خلاص، وهو كاشف قدامه يا دوبك، يعني مثلا انا عندي، ما فيش عندي هنا ده مقفول، حاجز هنا، فهو اخر حاجة يبقى شايفها قد ايه؟ لحد هنا كده مثلا. صح يا باشمهندس؟
اي نعم.
جميل. طيب لو هو لقى هنا سيارة واقفة او عطلانة، هل هيبقى في عنده مجال ان هو يوقف سيارته؟
لا، ما يكون عنده مجال.
بالظبط. يبقى احنا ايه اللي بنعمله عشان المنحنى؟ تمام، انا بخلق له هنا مساحة مكشوفة بحيث يبقى هو كاشف بعينه وشايف لحد هنا، تمام، بما يعادل المسافة اللي تسمح له ان هو يقف، عشان لو حب يقف هيعرف يقف. وصلت ولا ما وصلتش؟
وصل يا دكتور.
خليك معايا دي تاني، بس اعيد على الموضوع ده تاني كده. اوكي شباب، عشان نبقى فاهمين، انا لو قلت ان في عندي مثلا سيارة هنا، لو عندي المباني كلها جار الطريق ده مبنى هنا اهو، لو قلت ان السرعة بتاعت السيارة هنا كانت V equal 90 كيلومتر بر اور، تمام، حد يحسب لي الستوبنج سايد ديستانس للسيارة دي، هتبقى 25 multiply 2.5 بلس 25 تربيع على 2 في 9.81 في 0.345. حد يحسبها كده سريعا؟
مية وأربعة وخمسين بوينت ثلاثة وثمانين متر.
154.3 meters.
بوينت 8.
انت قلت ثواني، مترز.
متر.
انت قلت ثواني في الاول. Okay, the stopping side distance in this case will be 154.8 meters. Okay, based on this obstacle لو اخدناها كده هندسيا هو هيشوف قد ايه؟ هو هيشوف لحد هنا. تمام؟ هنقول ان المسافة دي يعني سي مثلا ان هو بيلف لقى سيارة عاملة حادثة ومقلوبة هنا. اوكي؟ لو المسافة دي تمام كانت سي 90 متر، يبقى في الحالة دي ايه اللي هيحصل؟ ساعة ما هيشوفها هو على بعد 90 متر. خلاص؟ مش هيلحق يوقف السيارة. فايه اللي هيحصل؟ هيصدم فيها. That's why we make this side distance offset. طبعا كل ما السبيد زادت كل ما الاوفست ده بايه؟ بيزيد. واضح ولا مش واضح؟ يعني كل ما يعني احنا دلوقتي لما بنشيل ده الدرايفر كان سي بقى ايه لحد هنا، بحيث ان المسافة دي من هنا الى هنا دي بتبقى greater than or equal 154.8 meters. واضح؟ مفهوم يا شباب؟
مفهوم يا دكتور.
طب جميل جدا. طيب نرجع تاني للمسألة اللي احنا كنا بنحلها الأسبوع الماضي، نكمل عليها. Okay. This is the example that we were solving last lecture, and we had here, let's read it. Okay, here we wanted the station for the point of curvature and the station for the point of tangent and the minimum horizontal side offset clearance for side distance. This is what we are going to calculate now. And the lane widening, we calculated this, and the transition length we didn't calculate it last time, and the key transition station, and the maximum service volume for this curved segment at level of service C. So let's go back and just calculate this this minimum horizontal side offset, side distance offset. So here what we have the speed that we calculated last time. It was 75 kilometers per hour. So the stopping side distance equal 75 divided by 3.6 multiply 2.5 plus actually it's gonna be 21 meters, 21 meter per second, 21 squared divided by 2 multiply 9.81 multiply 0.345. So this will be لا مؤاخذة يا شباب. So this will be 2.5 multiply 75 divided by 3.6 plus 21 square divided by 2 divided by 9.81 divided by 0.345. So this will be 117.23 meters. So based on this, again, we want to calculate this distance. Okay, so this is R and this is the stopping side distance. So we want to calculate the theta, the angle that corresponds to this. So theta equals 117.23 divided by R. The radius in this problem, it was 200 meters, multiply 180 divided by pi equals 33.58 meters. I'm sorry, not meters. 33.58 degrees. It's an angle. Okay? So the horizontal side distance offset equal R minus R cosine theta divided by 2. So it's basically 200 multiply 1 minus cosine 33.58 divided by 2.
8.53.
8.53 meters. Excellent. Type. How much, actually do we need if we want to add right of way to this road? Okay. Here it says that we have a 2-lane. It's a 2-lane, 2-way, and the lane width is 3.6. Okay, so out of the travelway, if we say, for example, that the original cross section, it was something like this. The original cross section of this road was something like this. So we have here 2 shoulders and 2 lanes, and here 1.8 meters, here 3.6 meters, and 3.6 meters, and here 1.8 meters. On the curve, what shall we have? That's for the normal, that's on the tangent segment. That's before going to the curve. On the curve, we will have something like this.
Doctor, please.
Yes?
The question is saying that we have 2-way and 2 lanes. Is it meaning that we have 2 lanes or 4 lanes?
No, we have 2 lanes, 2-way. That means, yeah, similar to what I'm doing. Okay?
How can we distinguish that?
If it say 2-lane in each direction, then it's going to be 4 lanes. When we say it's a 4-lane highway, for example, that means we have 2 this way and 2 this way. Okay, two lane, two way, that means one lane this way and one lane this way.
Okay, thank you.
وبعدين انا اللي كاتب المسألة اصلا يعني.
تمام. اوكي.
ماشي. اوكي. طيب يبقى هنا الشولدر it's not gonna change. اوكي. ده الشولدر بتاعنا 1.8 1.8. Okay, but we did in our calculation we had a lane widening, so basically what are going to be the new lanes? The new lane width is here 4.07. For practicality we don't use 4.07, we're going to use 4.10. يعني let me go back here and say this is going to be use 4.10. Why? To minimize the chances of errors. واضح؟
واضح.
So here يعني انت لما بتيجي بتيجي تعمل ديزاين لعمود، تمام، بتعمل راوندنج لأقرب كام؟ 5 أو 10. واضح؟
صحيح.
اوكي. هنا ده 4.10 meters 4.10 meters. Okay, so we calculate from the center. We calculate the offset from the center and we calculate this way. So we need to have this offset clear, which was I think 8 meters that we calculated, 8.53. We're going to use 8.6. 8.6 meters, and you can, you know, allow people to build here or make mark or whatever. Okay, so basically from the shoulder this distance must be clear. So this is what we call additional right of way. طبعا انت عشان تفرض على الناس انها ما تبنيش في المنطقه دي، هو حقك انت لحد هنا سي، ده ملكك كجهه مالكه للطريق، تمام. في عندك رايت اوف واي، سي مثلا رايت اوف واي كان بعد الشولدر، هنفترض ان الرايت اوف واي ends right at the shoulder، تمام. اي حاجه زياده انت تشتريها من الناس. واضح؟ مفهوم؟
مفهوم دكتور.
جميل. طيب يبقى الديستنس دي هتبقى الاديشنال رايت اوف واي هتبقى 8.6 minus 1.8 minus 4.10 divided by 2. فهنا دي 4.1 over يعني ده 2.05 يعني هنا we have 8.6 minus 5 8 هنا 3. So here yes.
ليه خلينا 4.1 بدل 3.6؟
Okay. You remember in last lecture we talked about lane widening in curves, right? And we calculated, you know, the new lane widths here on the curve, and we found that the new lane width on the curve will be 4.07 in order to accommodate design vehicles. Okay, so that's on the curve. We are going to have this lane width. It's 3.6 That's if you are going on a straight segment of the road. واضح يا خالد؟
واضح يا دكتور واضح.
ماشي. فهنا this is going to be 4.75 meters. So we need additional 4.75 meters, okay, in order to have a clear horizontal, offset for the drivers and to avoid any accidents and stuff like that. Any questions so far? ممتاز. Okay, this way we conclude the horizontal alignment for highways, and we move to vertical alignment, highway vertical alignment. As we mentioned, we have two components for highways. That's the horizontal alignment and the vertical alignment. Again, land is not flat. Okay, so if we take a cross section in for the alignment, we will find that we have irregular land, irregular profile. So basically, we try to approximate this profile and connect it with straight lines. The objective for the horizontal alignment is basically minimizing the cut. So, in this case, for example, you see that the profile is below the natural ground level. And here it's above the natural ground level. Here it's going below. Here is going, above it. So, in order to achieve that, we cut these parts. So, this is what we call cut. ده بنعمل له حفر يا شباب. تمام؟ ده بيتشال وبعدين بنروح هنا and we make fill. فهو اللي بيحصل ان احنا بنشيل من هنا وبنعمل ايه فيلنج هنا. طيب, the design objective for vertical alignment, the design objective is basically to minimize cut and fill. But we have constraints. First of all, we maintain level of service and capacity. Okay, at most we can allow for 2 level drops in level of service. And the grades should be comfortable for passengers and suitable for design vehicles. تمام? Especially trucks. Now we are talking about trucks, not passenger cars, because these sharp grades are difficult for trucks. Clear? So the objective, again, the design objective for vertical alignment is minimizing cut and fill. Okay? And the constraints is basically maintaining level of service and capacity. At most, we can allow for 2 level drops. Any question? Type. Vertical alignment, the operating characteristics on grades. We have passenger cars. For most cars, for the grade of 4, the range of 4 to 5% grade does not affect performance of or make loss in speed. But beyond that, beyond 5%, it affects performance of passenger cars. However, the situation is different for trucks. For trucks, just going 2% or 3%, it affects significantly the speed performance. Okay, and here we have this chart from the highway capacity manual. It shows for us the performance of trucks on vertical curve, vertical grades. واضح يا شباب؟ يعني هنا بيقول لك ان لو في شاحنة دخلت الطريق والطريق ده سي ان هو مثلا كان 5%، يعني احنا ماشيين على الخط ده، فايه اللي هيحصل؟ هتدخل هي الشاحنة هنا كده، لو مشيت 500 متر، the horizontal axis here is a distance in meters. ف if the truck goes here, let me just add this for you. لو الشاحنة دخلت هنا ومشيت 500 متر 500 meters. Okay, after driving for 500 meters, this is going to be the speed of that truck. That's going to be the exiting speed. يعني دلوقتي السيارة اوكي ماشي ستريت، بعدين طلعت على جريد مايل 5% grade, and here it's flat. Okay, so it was driving here at 90 kilometers per hour and drove on this grade for 500 meters. The speed of this truck once it finished that grade will be this speed, which is almost 64 kilometers per hour. However, it will start, excuse me?
Yes, sir. At the end of the grade will be 64.
Yes.
Okay.
Okay. For example, if it drives more than this, for example, say if it drives, let me just try to elaborate on this more. If it drives, for example, say sorry. This is, I think, 700. The distance from here to here on the horizontal axis, this is almost 700, I think. So if we have another case that we have a grade which is which is 700 meters. Okay, the exit speed here will be this speed, which is, I think, 54. واضح؟ طيب لو هو مشى لحد هنا، هنا بقى مش هنمشي ستريت لاين، هو كأنه مشى بهذا الشكل. خلاص لو مشى كيلو ونص 1500 هينتهي عند هذه السرعة اللي هي تقريبا 42 كيلومتر بير اور. واضح؟ اي سؤال اي استفسار يا شباب؟ طيب okay, we are gonna continue on this but next week inshallah we are, or if we have a quiz, let me just stop it here.